Okay, this last problem for friction is gonna be like very easy. Once again, we need to know if well, the force that we're applying is basically the one we need to just like make everything move. So probably a good idea is to start like doing our free body diagram. So we have our normal force going up, our weight going down, the normal force. We have someone pushing it like here, and we have the friction force that goes the other way. Okay, so let's compute the force that is necessary for us to start moving this block. And well, let's say that let's compute all the forces in X are gonna be equal to the force minus the static friction force because it's not gonna move. It's gonna be zero. And the forces in Y are gonna be equal to the normal force minus the weight, and that's going to be equal to 0. Okay, so from there, from the first equation, we know that the static friction force, it's going to be equal to uh, mu static friction times the normal thing. Okay, now this thing is not going to move. From there, we know that the static friction force coefficient is 0.6, and the normal force is the weight because normal force is equal to the weight, which is equal to mass times gravity, and this is going to be equal to, well, times 100 times 9.81, and this is going to be equal to 598.6 newtons. Okay, so just by looking at this, we know that this thing isn't gonna move. Okay, no matter what, this thing is not gonna move. So let me just like signal it like a lot that this thing is bigger than 500 newtons. Okay, so we know that this thing is not gonna move. So the friction force exerted by the carpet on the crate is gonna be equal to 500 newtons.